Okay, good morning, everybody.
Good morning, sir.
Karthik, if I don't start recording, then you should do it, okay? Because I do it on the cloud, okay? Okay, so today's class is very important. As discussing the last class, we were discussing about the doubly linked list. We have discussed about the creation of a doubly linked list. So today, uh, sorry, first I'll share the screen. Today's date. Today we will discuss about the insertion of node in doubly linked list. Insertion of node in the doubly linked list, right? So as we have discussed in the singly linked list, where we have seen that the insertion of the node takes place, that is four cases arise. The four cases are what? The first case is the when the list is empty, it is added as the first and that also becomes the last node. And when the list is not empty, then the case is inserted as the first node. And the case 3 is when the list is not empty, inserted as the last node. And then the case 4 is insert the node as an in-between node. So the first case, what happens is case 1, when the DLL is empty. That is condition is if
That equals to none.
start is equal to null, start is equal to null, then it is nothing but empty. It is not empty. So if it is empty, the case is like this. This is the start and this is the last. The last has a garbage address, start is null. So a node is being inserted, which is for example as 2120. So this is actually equal to null and this is also equal to null. Now we have to establish the link. This has to be established. So the start is equal to the new node so that
Itself.
it overrides the new node
Null
value.
as 2120.
Yes. And last garbage address is also overwritten with 2120.
Last equals to new node.
Okay. So the steps are what? Simply
Start equals to new.
start is equal to new node,
Last equals to new node.
last is equal to new node. These are the steps. Same as singly linked list. Okay. And now the case 2. Case 2 is when the list DLL is not empty and node has to be inserted as starting node, as first node. First node, that is when pos is equal to 1. When pos is equal to 1. So let us see when pos is equal to 1 how to do this problem, right? So let us take for example this is start. You have a doubly linked list. This, let us assume these are the three nodes which are there. The last, this is 2120, this is 3180, this is 1822. So what is this going to be? Null. and there is a link back. There's a link back. Okay, and start is equal to 2120. Last is nothing but equivalent to 1822. Okay, so this is 1822, and the previous this is 2120, and what is this value? 3180, and this is null. This is null. Is the diagram clear? And what is this value? Tell me. This is 3180. 3180. Okay. So now let us take. We are inserting a node, a doubly linked node, right? Which is this is null. This is null, and this value is also null. Which is, for example, at 4826. Now this link has to be broken, and we have to establish the link here. Okay, and as well, this value is going to be overwritten, null is going to be overwritten with the 4826. This also will be overwritten 4826, and so that the link is established. As well, this null has to be overwritten with the 2120. 2120. So there are three things which are happening here. One is the new node arrow RPTR.
PTRs.
RPTR is equal to start.
Start.
Okay. So this order is very important. New node arrow RPTR is equal to start. And then, right, then what is another one? Start. This one is this is nothing but what the first node left,
Start equals to new
yeah.
nodes.
No, start is equal to new node means what will happen? You are not, you are going to miss out this particular node value. Okay, right? This linking has not been done, back linking has not been done. So first to do that. So how to access this particular LPTR of this first node? It is nothing but start arrow.
Start LPTR.
Yeah, start arrow LPTR is equal to new node. Now you say, now you say start is equal to, now you overwrite start is equal to new node, so that all the three are going to overwrite. First is new node arrow RPTR. New node arrow RPTR is equal to start. The value what is there in the start, assign it here. Okay, why? Because this particular value which is there in the start is the first node, which becomes the second node. So it should be stored in the first node RPTR. And next is start arrow LPTR. That is the present first node, whichever is there. The left hand side of that left link should store the new node address. So start arrow LPTR is equal to new node. Now you change the link, that is nothing but what? Okay, this. So this is how the link is being established. Is this clear? So this is as a starting node, as a first node. Okay.
So can we do taking a temporary pointer for first can we do sir?
Yeah, yeah, you can take it, but I don't require a temp here because can be accessed by start. Okay,
Okay,
it can be
okay,
accessed by start. Okay, now let us go to the case 3. You please make a note of it. Then we'll go for the case 3, please. Case 3 is when position is equal to n. When the position is equal to, sorry, greater than n. When the position is greater than n, then it is the last node to be inserted. Okay. So the case 3, node has to be inserted as last node, that is pos is greater than n. This is the start node, this. So this is 2120, and what is this? Null. And what is this value? 4122. And what is this value? Next value? 2120. And this is 3180. 3180. And what is this? 4122. And what is this? This is null. Is the diagram clear? And what is this going to be? 3180. Right? So now what are we doing? We are inserting it as a last node. Let us take that this is the new node which has come up, which is new node. Assume that this is at 8136. 8136. Okay. Now how to make the links? Tell me. This is null. When it was created, this is null and this is null. Okay, right? So this rptr is null is not a problem. That is perfect for us. Okay, that becomes the last node. Okay, then last has to be overwritten. This value has to be overwritten with 3180, has to be overwritten with 8136. So this is 8136. If you write, then the list link is established. But before overriding that, this particular last node arrow rptr, last node arrow rptr is
8136.
yes, I yeah. Yes, this is accessed by last arrow RPTR. It is accessed by last arrow RPTR. Last arrow RPTR should be equal to new node, right? Before overwriting the last value. And also very important is new node arrow LPTR should be equal to 3180. 3180 is stored in last. So what are the steps which are involved here? Now tell me. New node arrow LPTR is equal to last, right? New node arrow LPTR, that is this value is overwritten with last, which is 3180. After that, this particular value which is there, that means this particular link has been established. This particular link has been established. Now I have to establish the link from here to here, right? So this particular no null which is there has to be overwritten with the new node address, that is 8136. So I'm going to say it as how it is accessed: last
RPTR.
arrow rptr
RPTR is equals to new.
new node. And then we are going to say now you change last is equal to new node. These are the steps which are involved when we are actually doing it. Okay, right? Is this clear? What happened, Rekha? Why are you putting on your video? Spurti Rekha, please switch off your video. Okay, right? So this is what is the last concept. And now the last case is case 4, which is now insertion of a node in between any two nodes. Any two nodes, right? That is position, that is pos is equal to 2 to n minus 1 is equal to 2 to n minus 1. That is the in between node. Okay, so into to n my n also, because when it is 10 nodes are there, 10th node I want to insert, means 10th node will become the 11th node. Okay, right? So this one. Okay, so n. Now let us now take how this works. Okay, right? So there's a start. There is no difference in the start, right? This is the first node. This is the second node. and this is the third node. Okay, let's take this as last. This is 3186, this is 2122, this is 4183. Okay, assume that I'm inserting at this particular location. This is first node, this is second node, and this is third node. So I am inserting at pos is equal to 3. At pos, that is pos is equal to 3 I have given. At pos is equal to 3. That means at the third position I have to insert. So the third node will now become what now? It will become fourth node. Fourth node. So there is no change in the last and there is no change in the first. There is no change in the last. There is no change in the first node. There is no doubt in that. Okay. There is no doubt. Only changes which occur is in between. Now assume that I want to make the change. So this is 3186. This is 2122. Got it or not? You agree or not? Okay.
Yes, sir.
So is the left node of this second node going to make any change? No. Is the right node of third node is going to make any change? No. Right. So what are the changes which are going to occur? This is the new node, for example. Let us assume this is a new node. So new node, and assume that the new node is at 8602. 8602. So now what will happen here is these links are going to break. These links are going to break, and links are going to be established like this. This is one link, right? And this is another link, and also the backlinks are going to be established. Okay, and also this link is going to be established. Is this clear? Right, that means can you tell now how many pointers are going to how many steps are going to get involved, right?
Yes,
So this was null, this was null, and this was null. Both the null values are going to change.
yes, sir.
Okay, and this is 3186 and this one 2122. This is going to change. This 3186 is going to be what now? This
8602.
8602, and this 2122 is also going to be what? 8602, right? But the question here is how do we access this particular this one? Now you go back to your single linked list. How did you access that nodes? You made
Temple.
it as made as temp and you have accessed it. Yes or
Yes,
no?
sir. Yes, sir.
Now same thing. Let us take the temp is here. Temp get it to the second node if you have to insert it at third, right? And you temp get it to the third position, third node when you want to insert it at the fourth. For example, you want to insert the node at eighth location position, then get the temp to 7. The temp to 7. So here I have given position as equal to 3. So where should be the temp equal to? It should
Second.
come to second node. Now tell me how to access this particular temp is at the second node, and this is the node RPTR is required to be changed. So how to access this RPTR? Now tell me. Temp arrow,
Arrow RPTR.
temp arrow RPTR. Very good. Now tell me I have to access this particular location, but this is not identified by any name. This is identified by the name, that is temp. Okay, but how to identify this? This is temp arrow RPTR is what? Now tell me here.
8602.
No, no, no. This is not chat. You assume now the change has not been done.
Okay, sir.
Temp is in the second node. What is temp arrow RPTR value? It is the third node. Got it or not?
Yes,
How
sir.
to access the third node? That is, this is nothing but temp arrow RPTR. If I take RO LPTR, if I take, what is this? Nothing but the left node, this one. Temp arrow, temp arrow, understand? Temp arrow, this is the temp, right? Okay. Temp arrow
Arrow
RPTR,
RPTR is equal
arrow LPTR is nothing but this R, but temp itself is 2122. Are you getting the point or not? So
to. Yes,
you
sir.
can directly temp say temp here. but that this temp value is going to be written here. But when I'm writing this value, this is the next node address 3186. Where is 3186 stored in now? Tell me.
Temparo LPT, RPT.
Bus, that's all. That's all. But when I'm accessing this particular value, now tell me how to access this particular location and make the change. I can't just say temp is equal to, right? I have to access this particular location. It is temp arrow LPTR, sorry, temp arrow RPTR,
RPTR, sir.
arrow LPTR. Arrow LPTR. That is what is very, very important. So I'm going to make the change first like this. So let us, before these values are overwritten, take this and store it here. Take this and store it here. Right? Are you getting the point or not? Okay. Yes or no? So this particular 2122 is going to be overwritten with new node. This 3188 is going to be overwritten with new node. Before this becomes overwritten, 3186 is overwritten. 3186 is now becoming what? The
No, no,
new no
RPTR.
node. This arrow what? Actually,
RPTR.
yes, 3186 is going to be the next node, right? So RPTR. And similarly, the LPTR, whatever is there, this LPTR 2122 has to be written here. Okay. So first you do that, make the change and then go ahead. So let us do like this. First is a new node, arrow, LPTR. What is new node arrow LPTR value equal to? New node arrow LPTR is nothing but it should be 2122. So it is temp. Directly I can say temp. Right. And then new node arrow RPTR is equal to RPTR value is nothing but the next node 3186. 3186 is stored in temp
Tempero
arrow
RPTR.
RPTR. So it is temp arrow RPTR. Now you have to make the change in the uh, temp arrow arrow arrow. First, you this is very important. Temp arrow. If I say LPTR, I directly change it to new node, then I cannot access this.
Yes, sir.
Okay. So first I want to access temp arrow LPTR,
RPTR, sir.
RPTR,
Arrow
arrow
LP.
LPTR. Two arrows you can use, right? Is equal to what? It is
Node.
nothing but new node. And now you access a temp arrow RPTR is equal to new node. So these are the four changes which we are going to do it when we write the program. Make a note of it. And then we'll write the function now. Then we'll write the function. Only one pointer is enough for us. Temp. Okay. Now let us write the function. Void insert. I require node star new node comma star temp, right? Okay. And what else required? Come on, tell me. Int value and then pause, then I, right? I is equal to, I'm going to start from 2. I is equal to 2 like last time. Okay, right. After this, what are we going to do now? Tell me. Char C, so that we can do, right. First step is what now? Tell me. Printf, enter the value. Printf, enter value. Where are going to store? Scanf percentile D ampersand val. Now new node gets created. New node is equal to node star malloc size of node. Okay, size of node. After this, tell me what is that? You have to assign the values, right? So new node arrow data is equal to value, new node arrow lptr is equal to new node. Both at a time I can give rptr is equal to null. So first null is going to be assigned to rptr, and that is going to be assigned as, one step only I can write. Okay, right. After this, now what is the next step? What is the next step now? Tell me. Now we have to check whether
Start equals to
yes. Okay, if start is equal to null, then it is the first node. So how to do it as a first node? Now Tama, tell me. Start is equal to new node and last is equal to new node. So, okay, so you have done with this. Now else now else what? If if so you have to take the position. You have not taken the position, right? Now you ask for the position. Okay, right? So now first step is ask for the position. Printf enter position, scanf percentile d ampersand pause. So if it is null, I am not taking the position. If start is equal to null, I am not taking the position. If start is not equal to null, then only we are taking the position. Okay, right? That means the list is not empty. Yes, you got the position now. After taking the position, what are we going to do now? The next step is, now we have to check
if
whether
cos equals to
pos is equal to 1, then like that. So I'm going for the next page. Before that, you can please make a note of it. Before that, you please make a note of it. Right. So now let us take in this first case is if pos is equal to 1. If pos is equal to 1, what does that mean? It means that it is the first node insertion. So already I have written the first node insertion. Come on, tell me what is the first node insertion? What is the first node insertion? That there are 3 steps. Please tell me that 3 steps what you have written, which you have already written. What are the 3 steps? Tell me. Okay. What are the 3 steps, everyone? New node arrow rptr is equal to new node arrow rptr is equal to start. Yes, then start arrow lptr is equal to new node. Start arrow lptr is equal to new node, and then start is equal to new node. So this is what is the now else part for this. If pos is equal to pos is greater than n. If pos is greater than n, it is the last node to be inserted. So if it is last node to be inserted, then how are we inserting it as the last node? New node arrow lptr, new node arrow lptr is equal to last. New node arrow lptr is equal to last, and last arrow rptr is equal to new node, and then last is equal to new node. Until unless you draw the diagram, you cannot write the steps of programming. Did you notice? Can you by heart? Can you remember? No. It is all depending upon your only thing is that how your diagram. If you're understanding the concept and the diagram, then is done. Then the last step is what now? Tell me. Else, else. Come on, tell me. First step is I have to move the value, right? So I is equal to,
temp
we have taken it as So I'm going to take temp is equal to start while I is less than position, right? I is less than position. What are we doing now? Tell me. Y is less than position. Okay, we are moving, right? Temp is equal to temp arrow rptr and also I plus plus. After this, then these four steps. Come on, tell me what are the four steps? What are the four steps, Amma? Come on. What are the four steps? You have to tell.
Arrow,
You have written already. New
new
node
node,
arrow,
arrow, LPTR,
new node arrow lptr is equal to
temp,
temp, and then new node arrow
LPTR,
rptr is equal to temp arrow rptr, and then temp arrow rptr arrow
arrow, LP,
lptr is equal to new node, and finally temp arrow rptr is equal to new node. This is what is the concept, right? So once these changes are being done, that is else is closed here. That now this else is closed, and after closing this else, what is required to be done now? Tell me. Next step is, after you close this else, what is required to be done? You have you have inserted the node. Yes or no? Right? So did you notice that when we have started writing there was one else which was opened for enter the position, so that else is required to be closed. Yes or no? You agree or not? So that else also you close it. That else also is closed. After that, before closing the uh, total this do, first of all you have to take the value, and before that you have to do the n plus plus plus. You have to do the n plus plus, right? So I'll do the next page, right? I'll do first is n plus plus. Now I am going to write printf enter, that is sorry, like to continue, like to continue, y oblique n, f flush stdin, and then scanf percentile c ampersand c. After that, then close while c is equal to y or c is equal to capital Y, close. And now close the function. Is this clear, everyone? Is it clear, my dear friends? See step by step. Let us see this program. Okay. First is insertion of the node. Case 1, when the DLL is empty, the condition if start is equal to null, then the node which is coming in is going to be the first node and as well as the last node. So make the change in the start, that is new node, assign the value of new node, and again the last also you assign the new node. Okay, so you are saying start is equal to new node, last is equal to new node. Then the case 2, when the DLL is not empty and node has to be inserted as first node, that is when pos is equal to 1. When pos is given as equal to 1, this node, the new node which is coming up, will be the first node. If this becomes the first node, the present first node becomes the second node. So whatever is the value, that second node address, that is the first present first node address which is stored in start, will become the RPTR of the new node which is coming up. So the new node arrow RPTR is equal to start. After that, I am going to take this particular the present first node which was there actually the first node. The LPTR is null, but that null has to be overwritten with the new node which has come up. So how to access this particular LPTR? It is nothing but accessed as start arrow LPTR, assign it as equal to new node, and thereafter change the value of start as equal to new node so that this is inserted as the first node. After that, what are we doing? The node has to be inserted as the last node when position is greater than the number of nodes. For example, this is the existing linked list. In this linked list, the last value is nothing but 3180, which is there already. A new node which has come up is 8136 is a new node address which has come up with this LPTR as null and RPTR as null. When this becomes a last node, then the RPTR does not change. RPTR remains null. But this LPTR is going to be the address of the present, actually now, the last node which is there. The last node which is there, the address is stored in the last. So what are we doing? The new node arrow LPTR you are assigning as equal to last. After that, you have to make the change in the present whatever is the new before this new node is coming up. There is a last node which is there. This last node is RPTR now is null. Actually, that has to be overwritten with the new node which is coming up. How to access this particular last new RPTR of this? This is nothing but last arrow RPTR. Last arrow RPTR. Assign it as equal to new node. Now you change last is equal to new node. This is a case of greater than n, right? And then the fourth case is insertion of node in between node. For example, I am inserting the node in the third position. If I am inserting the node in the third position, the third node will become the fourth node. Okay, so I'll get my temp to the second. So if I'm inserting the node in the second position, that means second will become the third node. My second node, new node will become the second node. So the temp would be at the first node only. That is the reason I value I'm starting from 2. I value I'm starting from 2. So 2 is less than 2 will not satisfy. So the temp will not move. Okay, so what is this temp is in the position where you want the insertion to take place. The as a fifth, for example, you are inserting at the seventh node, then I'm getting the temp to the sixth node position and keeping it. So when the temp is at this particular position, what you are doing is the temp arrow RPTR value is going to be the new node, and temp arrow RPTR arrow LPTR. That means the next node left. This one is accessed as the temp. The next node of the temp. If you take it, that LPTR is accessed as temp arrow RPTR arrow LPTR. So temp arrow RPTR arrow LPTR is equal to new node, right? And temp arrow RPTR is equal to new node. But these before overwriting these values, right? What are we going to do? Take this new node arrow LPTR and new node arrow RPTR, whatever is the values which are there. Okay, please overwrite that null values now with the previous node and the next node. So the previous node of this is nothing but the temp. The next node of this new node is nothing but the next node of the temporary node. So the next node of the temporary node, the address is stored in RPTR, temp arrow RPTR, and temp itself is a previous node. So new node arrow LPTR is equal to temp, and new node arrow RPTR is equal to temp arrow RPTR. So that is how we are doing the change. So first step is new node arrow LPTR is equal to temp, new node arrow RPTR is equal to temp arrow RPTR, and then temp arrow LPTR is equal arrow RPTR, sorry, temp arrow RPTR block LPTR is equal to new node. First you do that, this particular change you do it, otherwise this cannot be accessed afterwards. So temp arrow RPTR arrow lptr is equal to new node, and finally temp arrow rptr is equal to new node. This is the order in which you are going to make the change. So writing the function, I have taken node, right, data type. There are two pointers which you are being taken. New node is a pointer and temp is a new pointer. So int, we have taken val pos and I is equal to 2, and char c. Would you like to continue? For that we would like to use this char do, right, and printf first enter value, scanf you are storing the value in value, right, and you are creating the new block of memory by using the malloc function. New node is equal to node star malloc size of node, right, and once this block of memory is being created, assign the value to the data part of the new node, that is new node arrow data is equal to value, and then new node arrow lptr is equal to new node arrow rptr is equal to null. Means what will happen, null value first will be assigned to new node arrow rptr, that value will be assigned to new node arrow lptr. So both new node arrow lptr and new node arrow rptr will be assigned null. Now if start is equal to null, that means that the node which is coming in is the first node, which is itself is the first node, that means the list is empty. So this node which comes in, it becomes the first node and as well as the last node also. That is the reason start is equal to new node and last is equal to new node. Else part means you have to take the position at which it has to be inserted. Either it has to be inserted at position 1, first position, that is first node, or it has to be inserted after the last node, that is position is greater than n value, right, or it has to be inserted in between node. So we have taken the position, enter position, percentality, ampersand pos. After this, if position is equal to 1, then new node arrow rptr is equal to start we are taking. New node arrow rptr is equal to start. The same steps what I have shown you. Start arrow lptr is equal to new node and start is equal to new node. If else, if pause is greater than n, new node arrow lptr is equal to last. Again, last arrow rptr is equal to new node, and last is equal to new node. Did you see this both comparisons? New node arrow rptr is the start. Here, new node arrow lptr is the last. Here, start arrow lptr is equal to new node. Here, start arrow rptr is equal to new node. Here, start is equal to new node. Here, last is equal to new node. Did you notice position is equal to 1 and position is equal to last? How does opposites of that, right, rptr become lptr, and start has become last, and last has become start has become last. Here, lptr has become rptr and new node, and start has become last. Did you see this? And then the else part of the part is we have to move the temp to the position -1, right? So temp has to come to the node where you want to insert, that is the node -1 part. If you want to insert at the 8th position, then your temp has to come to 7th node. So start with temp is equal to start, and while I is less than pause, right, what you keep doing is temp is equal to temp arrow rptr, keep moving the temp by, that is I plus plus, you keep doing it. And once this is being done, the position temp has come to its correct position, then make the changes in the pointers. So new node arrow lptr is equal to temp first, then new node arrow rptr is equal to temp arrow rptr. So first new node left and right pointers you are assigning the values, and thereafter your temp arrow rptr arrow lptr is to be one first, otherwise that next node of the temp will be lost. Okay, so that is new node, and then temp arrow rptr is equal to new node. This is the order which you are following. And then after this we have done with the n plus plus, and then printf like to continue, yes plus, and scanf percentage c ampersand c, while c is equal to y or c is equal to y, continue this, right, and then close the void function. So this is what is the function insert. Any doubts in the function insert, please you can ask now. Students, any doubts? Any doubts in the function? Okay, if you there's no doubts, then deletion we'll do it in the tomorrow's class. I will just do the display function. Very simple. Void display. We'll do the display function. void display, right? Why, how to display that temp? You take it and you keep moving the temp, very simple. So node star temp is equal to, do it as null, sorry, temp is equal to start, initialize it, and int you take what is that, I you can take it, I is equal to start from 1, okay, right, start from 1. And okay, so what are we going to do? Simply you have to display. So while I is less than or equal to n, okay, I is less than or equal to n. And so before display there is one thing which we have forgotten. What is that? If the it is empty, you cannot display, right? So what are we supposed to do it before this? Come on, tell me first. You have to check if start is equal to null, printf list is empty, list is empty. Else part for this you are going to do while I is less than or equal to n, right? What are we doing? First printf percentile d slash t. What are we printing now? Tell me here. Please tell me what are we printing? Temp arrow data. Temp arrow data. And temp is equal to what? Next temp arrow rptr. You keep moving like that. And then I plus plus. Close. Else is closed. And the main is also, that is sorry, white display is also closed. Simple. If start is equal to null, list is empty. Else, while I is less than or equal to n, 1 onwards it should start. 1, for example, five nodes are there. 1 is less than or equal to 5. Printf percentage temp arrow data. First node will be created. This one will be done, and then temp will move to the second node. Temp is equal to temp arrow rptr, and I also will become 2. 2 is less than or equal to n. It will continue. 3 less than or equal to n. 4 less than or equal to n. 5 less than or equal to n is true. Then temp would be at the 5th location. It will print temp arrow this one, and thereafter temp is equal to temp arrow rptr, means temp arrow rptr would be null, so temp will become null finally. Then I plus plus. That's all. It's done. So without using I also you can do it. This, how can we do it? We can just say temp is equal to, we have started. While temp is not equal to null, you can check it. Put the condition. Okay, that also. So this is what is your program. So tomorrow's class we will go ahead with the deletion of the node, right? In the deletion of the node, is first node deletion or the last node deletion, or it is in the in between node deletion. Okay, we are going to do that. Okay, before deletion is possible, first we need to check whether the list is empty or not. If the list is empty, we cannot do the this one. So this is what. Um, Now I would like to check for the attendance. There are 57 participants, so removing me, it would be 56. So we'll see who are the two students, those who are absent. One is as usual 214, the other is 218. Yes, sir, two. Who is other person? 0214 is absent. Hmm. 20, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Where is 42, 43? 6242, 6243, 6242 and 6243. Is 6242 and 43 are there?
Sir. No, sir.
6243 he didn't rename, sir. Vishal Reddy. Last it is there.
62. Vishal Reddy, speak out. Vishal Reddy. Vishal.
Sir,
Why did you first of all come with without roll number?
sir, roll number. Sorry,
Ah,
sir.
సారీ నువ్వు ఏం రాసినావు చూపించు అసలు ఫస్ట్. Show me your screen, video. What did you do?
My camera was not working, sir.
So you show me now your what did you do? What did you write? I'm not giving you attendance. You meet me afterwards. 624, as far as I am concerned, 6242 and 6243 both are absent. What, Saitya, what is your doubt? Okay, I've taken the attendance. Uh, if you don't have any doubts, you can leave. Otherwise, you can stay for any doubts.
Excuse me, sir.
Yes.
Sir, about you shared the links, no, sir, recording.
Yeah.
Sir, in that you didn't share the topics. I mean, memory allocation of linked list and creation of linked list. That
Creation of
happened on April 8th and April 9th.
creation of
Creation of linked list.
single linked list, huh?
Yes.
And
Memory allocation of linked list.
was it recorded?
Yes, sir, you recorded every class except the last one. We shared that to you.
8th and 9th, huh?
Yes, sir.
Dates are what?
In April 8th and April 9th.
April 8th and April 9th. Okay.
Sir,
Ah,
sir, we have done n plus plus at the last no, sir, in the insertion.
ah.
But we have inserted the node at the first only, no, sir, before n plus plus only.
Where?
Insertion, sir.
Insertion. This is what, right? Insertion.
Yes, sir. We
Where
have
did you?
done first insert. First we have done insertion, no, sir, here only.
Where?
Position we have taken and we have inserted, no, sir, node.
That's what in the. This was one insertion which has taken place. If start is equal to null, in the else
Yes,
part,
sir.
one insertion will take place. Either of these two. That is the reason we are doing the this one. Not at the while loop is when the while loop is getting closed. At that moment only, we before that we have done the n plus plus.
Yes, sir. That only, sir. Before n plus plus only we have inserted, no, sir, node.
So we have inserted after that only we have to do n plus plus, na?
No, sir. Then the last node will be got, no, sir. Will got out, no, sir.
Will?
Will be removed, no, sir. If
Why
n
it will be
equals to,
removed?
if n equals to 5, if we,
No, if n is equal to 5, what will happen? No, position without, yeah, first of all, when are you going to, when do you say that the student has, sixth student has come? When five students are there, you will say that n is equal to 5. When the sixth student has come to the class, then only you will say
yes,
n
sir.
is equal to, yes, then that is
Sir.
what you have to add it only after the last, this one. N is to be incremented only after the insertion takes place. Don't do it before. Any other doubts? Don't have doubts, you can leave the class. You can attend the next class.